Welcome back to another episode of the Open Source Cafe. Today we have Benjamin joining us, and today we're going to talk about OpenFunction and open source. So, if you want to learn more about OpenFunction and want to get started with contributing, because we get a lot of questions in the community, Kunal, what are some of the great open source projects that we can contribute to? If you're one of those people, this video is for you. Before we get started, Benjamin would like to tell our viewers a little bit more about yourself.
Yeah, I'm Benjamin from KubeSphere team. I did KubeSphere serverless and observability team. I'm also the author of several open source projects, including OpenFunction, Fluent Operator, Notification Manager, and Kube Events, etc. So it's all a cloud native open source project. And today we are going to talk about OpenFunction. Let me share my screen. Okay. Actually, OpenFunction is a open source cloud native fast platform. It's not yet a managed service. It's installable. It can be installed on any Kubernetes cluster. As far as fast platform or serverless, we all know serverless is equal to fast plus BaaS, backend service. So backend service is very important to fast platform. A fast platform is almost useless if it cannot interact with the backend services, right? But it will be very difficult to for a function to communicate with backend services because the function can be written in many languages. And each language, the function of one language will have to connect many backend services. So it's very difficult for a user to connect to the backend service himself. So right, and to address this problem, we introduced Dapper. Dapper is actually another cloud native open source project. It can facilitate the communication between application and other backend services. So this way, OpenFunction use Dapper to for inside user function to connect the backend service on several cloud platform or open source services, right? Such as you can use Dapper to connect to AWS MQ or the Azure Event Bus or Kafka. So it's very flexible and easy for user to write a function. And let's come to an overview of OpenFunction. OpenFunction actually has three components. It's defined by the function CRD, and the first component is the build. OpenFunction use shipwright to manage Tecton to build the function source code into OCI compliant container images. Once the image is ready, it will be deployed to the serving runtime. Currently, we have async runtime and sync runtime. The sync runtime, we are using Knative as the sync runtime, and for the async runtime, we are using Kda to scale the function and using Dapper to communicate with the backend services. And also, we have events framework. The event framework is something like Knative eventing, but it's much simpler and easier to use. Here is another view of the entire OpenFunction architecture. So user create a function CR, and the function controller will trigger the build of the function. Once the function is built, it will be pushed to the Docker registry, and then the function will start up in the serving runtime, or either it's a Knative runtime or a async runtime. Both runtime can use Dapper to communicate with the backend services. This is the build process. We are using shipwright to drive Tecton to build a function. And this is the serving runtime. Currently, we have the sync runtime and the async runtime, and we are planning to implementing a pull runtime to speed up the cold start of the function. And this is the events framework of OpenFunction. It's very inspired by Argo events. Actually, I think the architecture of Argo events is pretty good. The difference between OpenFunction events and Argo events, I think, is the event bus broker is decoupled from the framework by using Dapper's PubSub building block. So actually, user can use any message queue as OpenFunction's event bus. He can use a Cloud MQ like Azure Event Bus or a Google PubSub, and he can also use open source MQ like Kafka, NAS streaming, etc. So this is the event framework. And we also implement our own gateway using based on the Kubernetes gateway API. We have our own gateway, and user any gateway implementation that implements the Kubernetes gateway API can be used as an OpenFunction gateway. He can choose any gateway implementation, actually. Yeah. And we have also a function framework. Function framework is used to wrap a function into a application and communicate with the Dapper, do all this stuff, and user will not worry about how to communicate to Dapper, etc. We have a plan to optimize the code start in the latest release 0.8. 0.8 release, we are using, we actually moved the Dapper sidecar from the function port into a separate Dapper proxy service. And this way, the function instance will be started much faster than before. There is no Dapper sidecar inside the function spot. So we have already finished this feature in the latest release. This is the plan to implementing a pool-based code start optimization. This on our roadmap. So, sorry. Let's take a look at the actually function example. All right. We can see here. Okay. We can take a look at the sync function example. This is how the case looks like. User issue HTTP request to a sync function. The sync function will communicate with Dapper and publish a message to the Kafka. And the Kafka will trigger async function and to up and running. So let's take a look at the sync function scope. It's pretty easy and pretty straightforward. Has the context and the payload. The payload will be extracted and sent to the target. The target is actually a Kafka topic, and this is the send is a abstraction of OpenFunction's communication with Dapper. So user only call this method, and he can communicate with the backend Kafka. And let's see how function is defined. here is how a function is defined. You can see here it's a Kubernetes CRD, and here is the build part. Here you can see how the function is will extract this source code and build it to an image like this. This is the build part. And once the build is ready, the below is the serving part. You can see here the runtime is a knative. The function has a output. It's called target. The target is actually a Dapper component, a Kafka component. It's defined here. You can see the Kafka address, the Kafka topic. This is how the sync function is defined. Let's see how the async function is defined, right? Async function is here. The async function just read the message from Kafka directly by Dapper. You can see here. It also has a context and a payload. The payload is from Kafka actually. It's triggered by the Dapper and sent by Dapper to the function. This function will just print the message from Kafka. The function definition is actually similar to the sync function. It has a build part, specify how the function is built, and the runtime is different. The runtime is an async function, and the scale option defines how the the async function is scaled, right? Yeah. Okay. This is important. This trigger defines how the function is triggered. You can see here, whenever the consume is 20, it will increase replica. Once the threshold is actually the lag is 40, it will increase another replica. So the async function has the input of the async function is from the Kafka, so it has no output. Of course, it can output the processing result to another backend service, but for this example, there is no output, just the input. The input is from the Kafka, the same Kafka as the sync function, and from this topic. And any message, once a message is published on this topic, it will trigger the async function to up and running. So this is the sync function and async function. And let's take a look at how we can run it. You can see here, we already deployed the sync function here. It has an address. Yeah, we can access the sync function from here. And now we are going to apply the async function now. And before that, let me edit the async function a little bit. We can set the main replica to 1. Okay. We can apply this async function. You can see here how the function is built. Okay, the function is starting to build. The build we are using Cloud Native build packs. It's inspired by a Google Cloud Function, and the build packs will you need to have a Docker file to build a function. The build pack detects the languages and build the function into a container images. You can see here, saving the images, exporting the images to a Docker registry. Now the function should be up and running. You can see here, the async function is also here. Let's see here. This is the async function. Both function, each function has a proxy. The proxy is responsible to communicate with the backend services like Kafka. And the async function, the sync function is scaled to 0. Let's send some messages to the sync function. You can see here it's starting from the 0. And we can, from the async functions log, we can see here the async function has received the messages, right? We can, it's real time. Yeah, this is how, I think this is the demo, right? So, can I, do you have any questions? This is how the demo works.
Yeah, well, thanks a lot for sharing. And let's say, you know, if someone is, let's say, using OpenFast, for example, would it be ideal to, let's say, switch to OpenFunction, or can you maybe share, like, if someone is using, let's say, was trying out Rust, for example, or Docker for Docker images. So do you have like any things in the roadmap, like what can folks expect?
Yeah, I think
It's just like Go functions.
Yeah, no, we have currently we support Go function, Java, and Node.js, and we have contributors to create Python function support now. So I think it's okay to use OpenFunction instead of OpenFast. It's OpenFunction actually has a more modern technical stack, and we are using some very cloud native component to compose the entire platform. And as you can see here, the very unique point of OpenFunction is its ability to communicate with the backend service with ease. User can, as you can see here from this example, the user just need to define to communicate with the backend service. He just needs to define our Dapper component like this, like here, and he can reference. He can receive the messages from the backend service. He needn't to connect to the Kafka himself, right? It's very straightforward. So this is, I think this is the unique point of OpenFunction, right? As you can see here, the sync function just need to call a simple method, and he can communicate with the Kafka and send the payload to the Kafka. It's very easy. I think most of the current fast platform actually doesn't have this ability, including OpenFast, and maybe some cloud platform, cloud fast platform doesn't have this ability to. So it's very unique. Yeah.
Amazing. Well, thanks a lot for sharing. And so one more question is, how can folks contribute to the community? So by looking
Okay.
Yep.
Yeah, in the OpenFunctions website, you can see here there is a contributing guide. Here you can see how you can open issue and submit a pull request. You can how to send the pull request, and also we have a developer guide. You can see here. You can see here there is a developer guide. It's quite straightforward. how to check out the code and make the images, etc. So there is also, we have a roadmap here. Roadmap is actually a GitHub project. You can see here are the items we're planning to do. And here you can see the in progress items. You can see here, if you are interested in contributing to OpenFunction, you can take an item in the planned column or the backlog column and start working on that issue. This is the roadmap, and we have also a community. You can see here. We have Slack. This is the SynSaf Slack. We have Slack here. You can see here. Yes, you can see here. But actually, we are more active in the Discord channel. Actually, we have many active conversation in this channel. It's our daily work on this channel, and we have also, of course, you can also join us in the GitHub through the discussion, etc. Okay. So that's all my sharing. Okay.
Amazing. Well, thanks a lot for sharing, and I'll leave all the links in the description below so you all can check it out. And do give the GitHub repository a star as well if you wanna, get notified and check out the open issues, join the community. The conversation doesn't end here. You can join the Discord community and you can carry out the conversation over there, ask your questions. And that's pretty much about it. Thanks a lot for joining, Benjamin. Really great talking to you, and really appreciate you giving the time. And I'll see you in the next one. Have a great day, everyone. Bye.
Yeah, thanks, Cameron.